afternoon, everybody, and welcome to another one of our virtual tours of outer space. My name is Josh. I have the rare special privilege of tuning into your house from my house using our planetarium software and StreamYard, I guess. But we should be sending out via Facebook and YouTube, so no matter which channel you are watching us through, we are delighted to have an opportunity to present some really fun astronomy content to you. So we are here to do a very special show. Normally in our programming, we have a cool idea or an expert, and we fly around to show you off what they know or what we've decided you're going to be seeing that day. But today is very different because you get to tell me where we're going to go. Our virtual tours are sort of total request universe. You get to tell us an interesting object, and I will do my very best to fly us to it. I, however, get to pick the first object, so I picked one that has been in my mind a lot today, and I hope yours as well. This is the planet Mars. And when we're checking out Mars, we are seeing it through the OpenSpace software. If you are excited about some upcoming Mars landings tomorrow, and you really want to check out where it's going, by all means, you should download the software and fly yourself out to Jezero. It is a really cool spot, and one we're going to be learning a little bit more about this Friday after the landing. Hopefully, fingers crossed, everybody has to wear red, is successful. We should be seeing a brand new explorer on the Martian surface to tell us all about what's going on there. So with that in mind, if you have a lot of questions about Mars, by all means, bring them on Friday and throw them at an actual expert. Laura wants to know if we can see Pluto and its moons. We absolutely can. Let's head on out there. Now, we can see Pluto and its moons through our software. You can kind of see Pluto through a really good telescope if you know exactly where to look. Seeing Pluto's moons, I don't think is possible with the average backyard telescope. I think you'd need a pretty big one to spot its biggest moon. That's Charon. So the rest of those moons, I think you might have to actually be in space to see. I don't think we actually had a chance to see Pluto's moons properly until we were basically at Pluto for some of these smaller ones. That was, let's see, I think Nix and Hydra were discovered. And you can remember which ones because the initials N and H are very significant in Pluto's history. Why is that? For New Horizons. So Nix and Hydra are a little bit of a winky homage to the teams who helped discover them. Now, looking in, you can see some of the orbit lines. The green one is showing us Pluto's path through the solar system as it goes around the sun. The blue ones are showing us Pluto and its moons. Count them up. We got 1, 2, 3, 4, 5 moons going around Pluto. Most of the mass of the lunar system, the non-Pluto mass, would be in Charon. It's about, I think, about a quarter of the size of Pluto, maybe about 20%. It's a big moon compared to the total volume of Pluto. And I think they are of similar density. So it's an interesting thing that they actually orbit each other. For proof, I can show you the center of the Plutonian system is right there. See the end of that green line? Now, that green line is showing us the point that everything is going around. So Pluto is orbiting that point, which is a little weird when you think about it. Pluto orbits the center of the Plutonian system. And then Charon orbits that center too. And then all the other little tiny moons are going around that too. So the center of the system isn't inside Pluto. This is a system kind of ruled by majority. There's not one object that dominates it gravitationally. And that, more than anything, I think is the challenging part of the planetary part of Pluto's definition, or at least I should say major planetary part. I would argue that Pluto as a dwarf planet could still be given planet status, even if it is a dwarf planet. But that's somewhat of a controversial statement in the field of astronomy. Evan wants to know, can we visit Alpha Centauri? Okay, well, I will do my very best to get us to Alpha Centauri. The worst case scenario, I think we can point out Alpha Centauri on our way out of the solar system. Nope, we don't have an Alpha Centauri object, but let's keep going out of the solar system, and I think we should be able to spot it, but let's make sure we're looking in the right part of the sky. Easy way to get us lined up. We can see Orion right there. You can see 3 stars of the belt right next to Pluto. The green line is pointing straight towards them. So we want to be looking in the southern sky, way down here. Okay. So we can tell we're in the southern sky. You can see the the smaller and greater Magellanic Cloud. And if I fly backwards, somewhere in this field, one of those bright, bright stars should be Centaurus. And when we get away from there, we should be able to see Alpha Centauri in that basic direction. It should be the closest star to the sun, right down there. I'm going to say that's Alpha Centauri. Let me see if I can highlight it with my mouse. Can you all see? Oh, right there. Right there. I'm going to say that's Alpha Centauri. So when we're looking at Alpha Centauri, that is a pretty significant distance away. How far away? Real far. It's about 3 light years and change. I think coming up on 4. So when we talk about an object like that, that is the closest major real main sequence star to our sun. In fact, it is the closest star to our sun. People had suspected there might be something small and dark that maybe came closer. There's ideas about maybe a planet called Nibiru. Those have no evidence to support them. The closest main sequence star to us is Alpha Centauri, and the closest non-main sequence red dwarfy stars are a little farther out. I believe that's the Lumen 16 system. And I don't know if I can. Let's try and bring up our brown dwarfs. Brown dwarfs are awesome. So if I go to this and we check this box, things might get a little wacky. Check that out. Now, what are these things? This is a map of the brown dwarfs near us. Now, you might notice, wow, that's a lot of brown dwarfs very much nearby. How cool is that? Well, an extra awesome thing here is that we have only really recently discovered and started to understand these objects. They don't make much light. The little bit of light they do make tends to be in the infrared, which doesn't easily pass through Earth's atmosphere. That keeps a lot of heat close to the surface on planet Earth, part of our greenhouse effect, but it also means that infrared astronomy is very tough to do from the surface of our planet. So when we're talking about seeing these brown dwarf stars, we really didn't know the population or have a good understanding of them until we started doing upper atmosphere astronomy by launching infrared telescopes, basically detectors on small rockets, building telescopes that detect infrared on the top of tall mountains, and even putting telescopes inside planes. If you check out SOFIA, is a wonderful, amazing spacecraft, or I should say plane craft that studies space. Aircraft, that's what you call plane crafts. That uses an infrared telescope built into its side to observe the universe around us and has taught us some amazing stuff. SOFIA is a wonderful observatory, and I am very proud of having gotten the opportunity to fly aboard it. It was really cool, if really cold, and really loud. We had a question from Jashari to see UY Scooty. I for sure know I don't have a UY Scooty object loaded up in here. But ultimately, even if I did fly us out to UY Scooty, it would look just like a normal star. And that would be deceptive because UY Scooty is not a normal star. It is an absolutely gigantic, monstrous star, absolutely unlike other stuff we've seen. And I believe was briefly the holder, might still be the holder of the largest star we've ever detected. If you want to spot it, it's in the scutum direction, but I believe even at that tremendous size, it is too faint to be readily seen from Earth. And I'm fairly confident in that given the letters that precede its name. So we went through the alphabet once to give everything a designation, and then we went through again with 2 letters to give everything that fainter than that a designation. So when you see something like UY in front of a star, it means it's a very faint object. Oh, Mary was kind enough to drop in some info about SOFIA. If you ever want to see a flying observatory, that is a really good one to check out. Evan wants to know, can we see binaries? So we can see binaries with our own 2 eyeballs looking up at the sky. Flying to a binary system, I don't know if I have any loaded up. I very much focused on nearby stuff for this. But let me see if I could think of a set. I will try and get that for us next week, but I don't want me to spend time poking around in menus to see if Josh can think of a good binary to search for to fly us to. I'm pretty sure I have seen some binary star systems depicted in software like OpenSpace, so I'm pretty sure they are out there somewhere. Ooh, MX Quattro wants to know, can we go visit the largest volcano in the solar system? That we absolutely can. So let's start off with the second largest volcano in the solar system. I'm going to take us out that direction. So where is the second largest volcano in the solar system? Surprisingly close to home. Out here on our wonderful planet Earth. So to give us a little bit of context, I'm going to take us to a different day, actually, because currently the Pacific Ocean has just blue. That would be a wonderfully clear day, but I think this is because we are showing you today's data, and our satellites have not finished taking pictures of all of planet Earth yet. But if we go back a day, we should be able to get some better textures. There we go. Now, looking around here, to spot the Hawaiian Islands, and that's where we're going, you fly off the west coast and then come down onto the surface of Earth. And once you get close enough for the clouds to disappear, it should be just about the only land there is sticking above the surface. You might have midway up there. So let's keep following. Yep, I think I've gone too far south. Everyone who's better at Earth geography than me is crying right now. I apologize. There we go. There's Hawaii. So if we wanted to see the biggest volcano on Earth, we go here, and I believe this is the second biggest volcano in the solar system. This is Mauna Kea. So when you look down at this guy, from above, it looks like a big mountain, to be sure. When you look at it from above the water, it looks like a pretty big mountain. But you got to remember that the mountain really starts at the base of the ocean. And when you take all of that into effect, this is a huge structure. So I'm diving us down onto the surface of Earth and tilting us as much as I dare. Check that out. You really get to see the shape of this thing tapering off into the water around it. Mauna Kea is super cool. But you asked for the biggest solar system volcano, so I'm going to take us out to Mars, because that is, of course, Olympus Mons. So when we talk about Olympus Mons, the name is super cool. Mariner Valley is named for the spacecraft that discovered it. That was Mariner 4, I believe, sent us back information about it. And you can see it right here. But Olympus Mons was not named for a spacecraft that discovered it. To the best of my knowledge, we've never sent a spacecraft called Olympus anywhere. When we talk about Olympus Mons, they tried to draw a parallel to a mythological mountain, even though it is a real mountain in Greece. That was Mount Olympus. And Mount Olympus was famous for being the home of the gods in Greek mythology. That is a pretty cool title to have. So when we look down here, you can see the Tharsis Plain. And it's 1, 2, 3 absolutely gigantic volcanoes. But this one is even bigger than the others. And it looks like we're going to get a super cool view, because at the time I just so randomly selected, Olympus Mons is right on the Terminator. So we should actually be able to see from the surface of Mars kind of an irregularity up on the surface over here, where Mars isn't completely round. That's right, this mountain is so gigantic, it actually sticks out from the atmosphere of Mars. It is an absolutely huge structure. So talking about Olympus Mons is one thing. Seeing it would be quite another. I would love one day for human beings to be able to land on the surface of Mars, hike up this thing, and send back photos. Mountains make incredibly cool pictures. You can see shadows of them cast at the clouds and atmosphere. Mars does have a little bit of clouds, a little bit of atmosphere, maybe enough for us to see a hint of some of the shadow. It would be absolutely cool. So one day, I really hope that Martian hikers bring their cameras with them and send photos back for me to see. Doug Mill wants to know, are binaries the norm? So when I was a young astronomer, and for a lot of astronomical history, we've been talking about how binaries are the most common kind of star we would see in the universe, where binaries would frequently have one star orbiting another, and that would just be the norm, that whenever we saw stars, we would see one star going around another. We still know of a ton of binaries. There are lots and lots and lots of them, but they are no longer held to be the norm, I would say. And part of that is the discovery of really low mass stars. Because while we have found plenty of companion low mass stars, like small stars orbiting a big star or two small stars orbiting each other, I think there are so many singleton low mass stars that we don't say that the average star has a companion anymore. The universe does not seem to have an even distribution of all of those places. Dennis wants to ask, can we see Jupiter? Oh, I think we certainly can. Let's head on out there. So Jupiter is a beautiful planet, to be sure. I have a special place in my heart for Jupiter because Jupiter was the very first planet I found by myself through a telescope. Ooh, that was a cool view. Check that out. So again, at the random time and the random place I picked, we almost bonked into, looks like Io as we were flying into Jupiter. That's pretty awesome. I wish I could tell you I planned that out. I didn't. That was just random happenstance. But looking at Jupiter through a telescope is a very rewarding experience. If you have a backyard telescope, it's going to be one of the easiest objects to see as a disk, not just as a point. If you point your telescope at pretty much any star, no matter how amazing and wonderful the star is, you will pretty much just see a point, a single point of light. When you point it at a planet, sometimes with sufficient magnification and a big enough telescope, you will also get a dot, but a teeny tiny one. And I will hate to say it, when you look at Mercury, when you look at Venus, sometimes it's a little unsatisfying to just get a dot. Venus can be cool when you get a phase to it, but when you look at Jupiter, you can really see another world. And I think what makes Jupiter so special is that it is a big planet. It does have those dramatic bands and zones on it. Zones are light, bands are dark. When you look at Jupiter through a telescope, you can make those out. And that, to me, makes this a really special thing because you are seeing weather on another planet. It might not vary in the exact same way that our weather does, but this beautiful world and the changes that happen inside it do have an effect on its surface, which means that over time we do get to see variation. For example, a couple years ago, actually, gosh, I'm dating myself, about a decade ago, one of the bands disappeared, just vanished. I believe it was the southern band. It was gone for quite a while, many months, and then eventually it came back. Why did that happen? I still don't think there's consensus. I think that the clouds of Jupiter are complex and changing in some pretty interesting ways, and we still don't have a perfect understanding of them. I would also offer, though, that weather systems, by and large, are just tremendously complex. We know a ton about Earth's weather, but I still think there are exciting, interesting parts that challenge our models and dare us to keep building that knowledge. So if we haven't figured out Earth's weather in its entirety, I think something as alien and wonderful as Jupiter is going to pose an even bigger challenge for us to completely understand. But that doesn't stop it from being a beautiful, wonderful place. You wanted to see some Jovian moons. I think we can make that happen. Let's try this out. Okay, so checking out Jupiter. Let's see if I can't turn on some of its lunar systems. Check this out. Ah, this says they're all on. What did I do? Oh, I'm not far enough away. There we go. So these are the major moons. I'm not seeing any minor moons, but we definitely have those in here. I will search that out again, and we can see it next week. Great Red Spot, though, I can for sure offer you that one. Great Red Spot is easy to pick out, and I can also show you my favorite feature on Jupiter currently. Because Jupiter is changing, we don't have continents or craters to show you, but we do have persistent storms. So the Great Red Spot, we know, is probably several hundred years old. It does seem to be changing. Some people think it might be disappearing or getting larger or getting smaller, depending on the paper you read, but it is changing. Roger wants to know the bands and zones colors of Jupiter's atmosphere. They are sort of temperature and compositional variation, which gives it this distinctive color, sort of the reddish color, the brownish color, the yellow color. If you look at the right photos, you can also see some very delicate blues and whites, and I think that is just absolutely gorgeous. So checking out these features is something really special, and if you want to see a really great treat, check out the recent Hubble photos of Jupiter. They are beyond compare. Just wonderful to look at. Okay, Evan wanted to know, can you show us where Voyager 1 and 2 are? Again, I don't think I have those loaded up, but they are things that exist. We do have that data. What I can do is take us the correct distance away. So I'm going to take us, so I better be parented to Earth if I want to do this right. I'm going to stick us to our planet, closer in the solar system, and then fly us out about 19 light hours. Okay, so if you were clinging to the side, excuse me, we're at about 20 light hours now. If you were clinging to the side of Voyager, this is what the universe would look like, minus Pluto's little gray trail, or little green trail. Take a moment, though, and if you are familiar with constellations, look for a constellation. I think this is so cool. When we are out here looking at this kind of scene, the stars really have not changed at all. They're still exactly where we would see them from nearby. And that's because in order to get to see some variation, we would have to travel way farther away. So let's try that out, actually. From right here, let's pick out a constellation that's easy to recognize. Right now, I see Scorpius directly on the other side of our little green solar system. So if you keep your eyeballs on Scorpius, I'm just going to fly us backwards. You can start to see some of the nearby stars until you go all the way out here. We are seeing stars that are part of the nearby constellations that are very close. Some of them are very far. Turns out a constellation is a very bad organization of distance. It's a pretty okay organization of a kind of a cone in our night sky. So out here you can see the most distant stars that human beings see as bright and are part of constellations. All fall within, I don't know, a couple of thousand light years of Earth. When you get out to here, you can see how big all of our constellations are. The stars we really see as bright in the sky are compared to the Milky Way. I forgot what I was supposed to be talking about, but I'm having a lot of fun talking about this. So this is what happens when you give me an inch. I take several thousand light years. We were asking about Voyager 1 and 2. So a good question. We inscribed plates on Voyager with messages for an alien race. You can see the Voyager plate. Looks super cool. And also directions on how to put together a record player, because records were really cool at the time. And if you put the record player together and you put the record on, you'd hear theremin music and stuff from the Children of Earth. There we go. Mary just happens to have it queued up because she's magic. But when we look at this somewhat interesting record cover, you can see a definition of the grooves on a record up in the corner. You can see the direction a record's supposed to be played. You can actually see that spiky thing down in the bottom left is a return to sender address based on a bunch of pulsars. So those pulsars have very unique time signatures, and this was supposed to position in 3D space exactly where our solar system was so that people could figure out who sent this to them. So there's some cool stuff on this, to be sure. But the question is, how long is it going to be before this bumps into somebody? Well, if we aimed it at the nearest star to us, about 80,000 years. That's a long time. However, we didn't aim it at the star closest to us. We aimed it at a big cluster of stars. So it is going to be a lot longer until this reaches that cluster. So Voyager 1 and 2 ostensibly were designed so that aliens could pick it up and figure it out. However, I think a lot of people would agree it seems like it was most intentionally designed as sort of a time capsule, that if human beings ever create fast enough travel, we would one day catch up to those plates and maybe listen to sounds recorded long ago in human history, which is still a cool use case for it. Absolutely fascinating and not a bad thing at all. But the biggest challenge, I was researching a paper about how humans might communicate with aliens. It was very fun. I can't encourage you enough to dive into it. There's some really cool subject material. But the thing that I was left with is this is very presumptive of aliens that have eyeballs and fingers just like us. That if aliens don't perceive scratches on a record surface easily, the Voyager spacecraft are not going to be too successful. Even if they manage to catch up to them, then the question becomes, can you build a spaceship without eyeballs and a sense of touch? The answer? I don't know. Oh, great dark spot and rings of Uranus. I think we are overdue for a trip to the outer solar system. Let's go check out Uranus. So I'm actually super curious about this as well. Does Uranus have rings? Intellectually, yes, Uranus does have rings. Does it have rings in the software? I don't see them. But I can point out something interesting. They would be parallel to the moons, at least the major moons of Uranus. So right here, we would see those rings going sort of top to bottom, not side to side on our screens. They would be along the plane of those major moons. So that tells us something super cool. Immediately, the rings of Uranus would be perpendicular to the rest of the solar system, which is an interesting feature to be sure. One we thought was sort of unique for a while, but now we know there's a lot of interesting tilts in our own solar system. Not everything lines up perfectly. The other question was the Great Dark Spot, and for that we're going to have to head off to Neptune. So when we look at Neptune, you can see kind of similar features to Uranus for sure, in that it has light and dark clouds. It's got a very blue, beautiful color on its surface. And again, it does have rings, but I don't see them. But you can see variation in the darkness of the clouds. So you can see very dark stuff down around the South Pole there. You can see lighter clouds up here. If I keep going around, eventually we will see a dark spot. Now, when I was a youth, we learned the factoid that these were similar storms to what was going on Jupiter. But I believe in the years since, we've actually uncovered that this is different. This is more of a low pressure spot and sort of like a dent on the surface of Neptune. That's kind of cool that this is a cavity, if you will. Not that Neptune has poor dental hygiene, just sort of a recessed spot on it. But yeah, we are always learning more about these objects, even though we haven't sent a spacecraft here. It turns out Voyagers 1 and 2 that we sent out to go do their tours of the solar system, only one of them successfully completed its grand tour. That was Voyager 2. It sent back some pretty good, for the 90s, photos of the surface of Neptune. But we haven't really gotten better images since. I'm still showing you those same photos taken in the 90s because we haven't sent a follow-up mission in all that time. When is the next one scheduled? Never. We currently don't have one scheduled. There had been some ideas about sending more missions to the outer solar system, but we are long overdue. There's a ton of stuff we should know about these planets in our solar system that we simply don't. Why is that so important? Why do we need to know about ice giants in our own solar system? Because we have found tons and tons of ice giants around other stars. They seem to be a very common kind of exoplanet, and they are still a very mysterious one. So I see tons of awesome suggestions pouring in. I think we are a little short on time, though, so I'm going to defer those to next week. I spent way too long talking about the galaxy because I love galaxies. But if you had an awesome point and you are resentful of the fact that I did not get to it, by all means, tune in next week, drop it in the chat, and I will do my very best to fly there. And if you say, hey, I asked for this last week and you didn't fly there, I will make extra special sure to go fly to wherever you tell me to go. Thank you all so much for tuning in. It is a real joy. If you want to check out OpenSpace for yourself and do the tour I just did and fly to your favorite object, download it at the OpenSpaceProject.com. And other than that, thank you all for joining us again. My name is Josh. Thanks for tuning in to Morrison Planetarium's feed. We miss you all. We hope to see you again in the planetarium sometime soon. But have a wonderful rest of your day, your Wednesday, and we will see you next week.